Here we're going to look at question 19 from section 1 of the NSAA 2018 paper.
In this question, we're told that we start with a nucleus X and that via a series of decays, this nucleus X decays into a nucleus Y. We're also told that in this series of decays, that we have 5 alpha particles emitted and 2 beta particles emitted. The question then asks us, how many fewer protons does nucleus Y contain than nucleus X? So how many protons does our final nucleus contain compared to our original nucleus? This is all the information the question gives us, so let's go ahead and try and find an answer. Let's begin by considering the alpha particles emitted in our decay. If we think about a single alpha particle, we know that it has a mass number of 4 and a proton number of 2. This proton number of 2 means that the alpha particle has 2 protons in it, so with each decay, the X nucleus shall lose 2 protons. Therefore, if we lose 5 alpha particles, then the contribution of the 5 alpha particles shall result in X losing 10 protons. There we are, so that's all we need to think about with our alpha emissions. Let's go on and look at our beta minus emissions. Now you could be forgiven for just thinking that a beta minus emission is just an electron leaving the nucleus, so why would it affect the number of protons? But it's important to wonder where the beta minus emission comes from. So the beta minus decay begins with a single neutron, and this neutron can decay into a proton and a beta minus particle. Now an easy way of remembering this is by using conservation of charge. So we know that initially our neutron has a charge of 0, and our proton has a charge of +1, and our beta minus particle has a charge of -1. Therefore, we have a final charge of 0. So charge is conserved, it begins at 0 and ends at 0. Now if we look at our little diagram, then we can see that with each beta minus emission, we get 1 more proton in the nucleus. So, 1 beta minus emission results in 1 more proton in the nucleus, and therefore, if we have 2 beta minus emissions, we shall gain 2 protons. Now that we've considered both of the different types of emissions, let's see what the number of protons, or the difference in the number of protons is. So, we lost 10 protons with the alpha emission, yet we gained 2 protons due to the beta minus emissions. Therefore, in total, we should have lost 8 protons, giving an answer of B.